Yeah. Shiroko is gone. Okay. All right. Derivative of a constant function. These are the shortcut rules that the internet has been trying to tell you about for when you look something up. Okay. Now, once you know these, you don't have to go back to the f of x plus h limit la la la. Okay. Now, if you forget them, that means you have to memorize them. Okay, because if you don't memorize them, you get to go back to the limit as h approaches 0, or the limit as x approaches 2, whatever. Okay, so there are several. We're going to talk about 1, 2, 3, 4, 5, 7. I put them out a little out of order for a reason. We don't have to get to all of this. Certainly don't have to get to 5. That's why I put 5 and 6 really are on the other page. So, but this one's an easy one, so that's why I put it here first. Okay. All right. So, derivative of a constant function is its slope. And for a constant function, the derivative must be 0. So, what's the derivative of time? 0. Because remember, 5 is this line. Okay, and the derivative anywhere, the tangent derivative anywhere, the slope is 0. The derivative is the tangent slope. Okay, what about y prime over here? 0. Okay, so here's your -2. Slope is 0. Don't forget, the derivative is slope. Okay, that's when it's just all by itself. All right, now the power rule you will love. The power rule takes the derivative of x to a power. That power can be integers, positive, negative, fractions, anything. Okay? So I think I put a radical over there just so you know to transfer it. Okay. So here's how it works. You take the n and you pull it around the front. And then you decrease this power by 1. Okay? And we already talked about that a little bit, right? Because when we were doing the slopes of the derivatives, you were like, wait, that's 1 less power. Okay? All right, so over here, y prime equals what? 4x to the third. Pull the 4 around, x to the 4 minus 1, which is to the third. Okay? Here's a half. So, you pull around the half, t to the -1/2, which we could write as this if we want. How else could we write that? There we go. Okay? So these two are basically the same problem, aren't they? Except with a different variable. Y prime then is, first of all, you'd say, oh wait, I've got to change this to a power because I know how to do a power. All right, I don't know how to do radical rule. I don't have a radical rule. I have a power rule. X to the -1/2 is y prime, and then I'm done with it. Okay. Now I don't know that you were watching me. But please note, I did, and then I fixed it. Did you all catch this, that I didn't have this?
Oh, yeah, you have to make sure.
Right, because it's not equal to y, people. Okay, thank you. All right, so we want y prime. Allie, what's your question?
Does it matter, like, on that?
No, it does not. Good question.
I know you're probably not going to ask this, but if you did, like, for f prime t, where you could get like multiple different ones, would it be okay to do like the equal, like if you were doing like, if you were like list all the possible like ways this could look or something like that?
Nah, I'm not going to do that. Is that what you're asking me?
No, what I'm asking you is, would it be correct to just do like the equal for the f prime of t?
You could do,
Or could you just wrote?
you could write either one of these. Is that what you're asking me?
No, I'm asking like if you wrote like equal like that. Like, because you're not allowed to do it for that.
Yeah, that's fine. Yeah. Because yes, because this equals this, which equals that. Yes. We don't want to make sure that's a not, then that's a negative. Okay, so those are single. We got the constant rule all by itself. We got the, let's put those two together. A constant with a power, like this. Okay? The constant multiple rule, last year my DC class had a horrible time with it. They kept wanting to do something else with it. But anyway, it says take the C out, and then take the derivative of whatever this is left, and then put it out. So for example, y prime, I'm going to take the C out, and then take x to the first prime. All right? Now, I'm going to use the power rule on that. This one comes around. This decreases by 1. So what is that? 4. The derivative of 4 times x is 4. Okay? You don't get to take the derivative of 4 by itself. You take the derivative of 4, you take 4 times the derivative of x. That's the constant multiple rule. It should remind you of the limit rule that we pull the constant out and then take the limit of the rest. Okay? Same idea. All right. 2x cubed. All right, f prime. Go ahead and do it. And then we'll work it out slowly. You're going to get really fast with this when you're done, when you got it. All right. What'd you get, Sarah?
I got 18x squared.
18x squared. Okay. It's a little heavy. You want to get something different?
I actually did
6x squared sounds a lot better. Okay, let's work it out. And it's almost more complex when you work it out like that, but you save the 2, and you take the derivative of x cubed using the power rule. Power rule says, pull the 3 around, decrease that by 1, and then 2 times 3, 6x to the second. So what'd you do?
I squared the entire 3x. So I got like 9x squared.
Okay. So eventually you're going to multiply the 3 times 2, and then decrease that by 1. You got it. It's real quick. Okay? All right. This, you want to try that one by yourself? You got it. Good. Good. But what is it? 3 on 3.
You just said, what is it?
I know. Is that it?
Yeah.
Do you just get used to doing on some of these so much that you don't think
Yes.
we just I'm sure.
Okay. So y prime. Don't forget your y prime. Don't start this equals. 3 is being saved. We're changing, actually we're going to change this to 3 times x to the 1/2. All right. And remember, y equals that. So that all equals y. That's totally legal. Okay. So the 3's get saved. X to the 1/2. We're going to use the power rule. So 3 1/2 x to the 1/2 minus 1, which equals negative 1/2. Or this one. Either one of those are good. Typically, like if you're checking the back of the book, if you start with a radical, they will end the answer with a radical. But it doesn't make that one wrong. Okay? Does anybody have a question on that? Constant multiple rule. Okay? Whatever and we're going to get more rules. We don't have very much. We have the power rule. That's all I'm working with right now. But we're going to get more that you're going to add on to. Good question? No? You're good? Okay. All right, let's try the sum and difference. Now, this should totally remind you of the limit, where you take the limit of the sum as the sum of the limits. This is the same thing. We're going to add some constants, some power rules, and some constant multiple rules, and we're going to add them together. But basically, the rule for sum and difference here is that the derivative of the sum is the sum of each of them, and then add them up. Derivative of the difference is the difference of each of them, and then subtract them. Okay, so let's try these couple of examples. All right. So basically, the sum rule says I'm going to take the derivative of 5, the derivative of x to the 5th, and the derivative of 3x. And I'm going to either add or subtract them. Okay, what's the derivative of 5, Hannah? 0, good job. What's the derivative of x to the 5th, Abby? Good job. What's the derivative of 3x, Lindsay? 3. Good job. Simplify. We don't need that 0. We're done. Okay? Now think about how much work that would have been to do this. Yes. Think about this just alone. Oh my gosh. Okay? So you don't want to forget the rules, because that's what we got to go back to if you forget the rules, and that's would be dreadful. Okay. All right, go do that one. Yeah, it is. Yeah. Yes. Okay. All right.
Can we go back and retake our last one?
You have to use the definition derivative. All right. What's my prime, Allie Rivers? Right. And hopefully that's what.
I'm always missing the best one to say.
I know. Hopefully that's as quick as you can do it. You look at it, you can do it. If you don't have to do any manipulation, but here's the rule. We're taking the derivative of 6x, taking the derivative of 4x cubed, getting 6 and 12x squared, and we're done. Okay? All right. Okay, now, this is going to look like what are you and me? Okay, so, E is kind of a big deal. It doesn't get as much recognition as pi, but it's equally as important. Pi is like for the lower level student. E is for your upper level students. Okay. E is the number, this is its definition. Okay? If you're like, what is E? That's what you say. And you sound like a complete weirdo, right? Okay, but what that means is the function e to the x, remember what that looks like? E to the x looks like this. Is the exponential function whose tangent line at 0, 1 is exactly 1. Okay? Slope equals 1. Do I need you to know that? No. Okay, I'm just saying that's the background is E. Okay. So let's get our calculators out and show this one, because it's the easiest way to show it. You're going to put in e to the x in your y equals, and then if you have the derivative in there from before, just leave it. I like to just honestly leave that thing in there because I'm going to use it a lot. And you don't have to turn it on and off, right? So it's not graphing every time. So you're going to do e to the x. Go over here. Now there's 2 ways to do e to the x, but this key's going to be easier for you right here than the caret e. Okay? All right, now I have my derivative plugged on, but of course we know what e to the x looks like. There's that. Okay, now put in, if you haven't, put in 2y2, the derivative of e to the x. And you can do the bars thing, or you can do the, but I have it turned off now, this is why it didn't show up.
We have the x.
X, if you want to graph it, it's always x equals x. Okay. All right, so graph. There you go, math 8.
Thank you.
There you go. Red and blue make screen. No, purple.
Okay.
Okay.
Isn't it d over dx?
D over dx. D over dx, and then e to the x, and then x
Right.
equals x.
Yes.
I didn't graph this line.
Make sure I have a good window then. I'm just going over the top, you can't see it. If you want to make it different, I graph it again. Okay, now we do 1 and then 2. If it's the same thing, it won't do it again. It doesn't, you don't see it like my color does it? Okay, so the point in doing all this is that the derivative of e to the x is what? E to the x. Okay? Now, that doesn't make e to the x squared or e to the 2x or e to the 4x. That's all different. Just plain old e to the x derivative is e to the x. Okay? So we're going to throw that in here with sums and difference. Let's try it. Let's say, example, y equals 5e to the x. Okay, find y prime. Should be done. What is it? 0, 0. What? You're going to take the 5 out, and you're going to take e to the x derivative. 5 e to the x. Yes. Okay. That's it. Now, did you just do that constant thing that you went to 0? Yes. Don't do that. Only when it's itself, by itself, do you want to do that. We did addition or subtraction. Yes. All right. So y equals 6 minus e to the x plus 4x cubed. That's y prime. It's all right. You're just getting used to it. But by the time you finish the homework assignment, you should be pretty quick. Some of us will be quick.
Does that mean the homework assignment's going to go quick?
Should. It's a few tricky ones. Okay. You ready? What'd you get, Allie Creamy? Nice. Okay. You did 6 prime. This is like a -1 times e to the x prime. This is 4 times x cubed prime. I'm just spelling out what you're doing. This is 0. This is 1 times, what's it? Derivative of e to the x. E to the x. This is 4 times 3x squared. Pull the 3 around, decrease that by 1. There you go. That's a simplified version. Nice job. Okay. All right. So the e to the x. But be careful. This. Let's figure this out. I bet you can figure it out. It's not e to the 2x. Just saying. Remember what this equals? Is it,
Or would be, would be
Wait.
2x minus 1.
Okay, you don't have to do that. Sorry.
Yeah.
Sorry. I was thinking of this.
Is that what it is?
Here we go. You can do this one. Because you know what that means. What is, if you're adding the exponents, what are you doing with the base e's? You're multiplying them. Good at it. Okay? That's what that means. And what's the derivative of this? And this is a constant. So it's the same thing. Okay? But don't assume that was a bad example because I'm trying to tell you what the same is. Don't assume that
I'm
it's
just not going to write that example.
okay. All right. Yeah. Okay. All right. Normal line. We're ready. Yeah. Okay. Good. I just wanted to do, yeah. Okay. All right. Normal line is what they call perpendicular line. Okay? You got to remember that. So if you have a tangent, let's say we have a y equals x squared, and you have the tangent line, let's say at here. So there's your tangent at, okay? The normal line will be perpendicular. That's your normal line. Okay? Which is your perpendicular. Okay? And typically it's at that point in tangency is when they're talking about it. Calculus that is. Okay? So that's your normal line. All right, so let's do an example. We're going to use tangent line and the normal line, which is pretty normal. Okay. Find the equation of the tangent line and the normal line to the curve y equals x radical x at the point 1, 1. Okay, so now we're going to apply some of our rules. Wait, what is that as far as constant, power? It's not an e to the x. It's got to be a power. Because we haven't had a product yet. So what is that as far as a power of x? 3/2. Yep. You're adding 1 and 1.5 to get 3/2. So you got to be able to do that. That's good old-fashioned algebra. Okay, so this is our function. We need y prime. Why do we need y prime for an equation? What does it signify? The slope of what? The tangent line. Okay, so just to be clear, I'm going to write the slope of the tangent line equals y prime. All right, y prime will be real quick now. What is it, you fake? Very good. She pulled the 3/2 around and she decreased that by 1. Okay? Now, we have it at point 1, so we're going to do x equals 1. Okay?
You also write that as 3 over x squared or xx.
No, that's a positive 1/2. You don't want to pull it to the bottom.
It would be 3 radical x over 2.
Yes.
That's fine.
Okay. So 3/2, what's 1 to any power? 1 to any power is 1, right? So your slope of the tangent is 3/2. All right. Okay. So whatever it's going to take when you plug in, whatever you want to do is fine. You just have to make sure that it's easy for you to plug in. This is just plugging in your x equals 1. Okay, tell me what the equation of the tangent line is, Sarah.
The equation of the tangent line is y minus
Nice. Okay. All right. Equation of the normal line. Sydney, you give me the normal line equation? What is she teaching you? Okay.
Here's change the slope.
So negative what? All right, Sydney, what is it?
So y times 1 equals 2/3. No, that's so wrong.
Negative 2/3. That's right. X minus 1. This is the opposite reciprocal of 3/2 or perpendicular. Perpendicular. Okay? So that's what I want. This, well, and this. Okay? So the slope is the quickest part of that now. It used to be the longest part of it. Okay? Any questions on that? Now, go ahead and graph.
3 to 10 minutes.
Just, okay, then don't. All right, let's do this one page. All right, find the slope of the tangent line at x equals 0. All right. Slope of the tangent line. Whenever you're ready, raise your hand. Slope of the tangent line. Should be done. So what is the equation of the slope?
So the 12x squared minus 2.
So you're plugging in 0, and you got -2. Okay. Anybody not get -2? All right. Equation of the tangent line.
No, we found the slope.
Ready? Sir?
Is it, y plus 1 equals -2 x? Because there's a 0.
Yeah, you can leave the 0 or not. But yes, this went to -1. You had to plug in f of 0, remember, equals that plugged in. Okay, so that's how that became plus. There's your slope from above here, x minus 0. You can write it like that if you like. Okay? You don't even have to bother getting rid of it if you just want to plug in. Okay, measure the normal line at the same point. Allie.
Y plus 1 equals x minus 0.
Very good. Okay? Or you could, yeah, if you're already thinking ahead. And you can do, the back of the book will always give you at the end slope-intercept form. Please know you do not have to change it to slope-intercept form. If you do not want to, unless you want to graph it, then it would be easier if that one's over on the other side. Okay, slope of the secant line. Secant line. That was when we first started the derivative. What's that? Slope of the secant line. Just do 2 points. We're doing an interval. 0. I believe it was -1 and 5. What happens when we plug in a 5? That's what that means.
0.
That's the interval on x that we are doing. Okay. We should pull up a graph here, but go ahead and plug in your 5, and I'll pull up the graphs just so we can have a visual here.
Is that wrong? It seems huge.
Anyway, it's huge because we had the 4x cubed, so yeah, it's going to be big.
It's 489.
All right.
Right.
The only equation we have. We have another one. What other one would we do? Okay. Where your head was. Oh, wow. Am I?
Yeah.
Why's that?
She was sassy.
Who have I been sassy to?
Sarah, Phoebe, everyone that's just been sitting in this room.
What, me? No.
Yes.
Giving mix up. Oh, that's supposed to be triple. Nice.
The slope is 98.
Okay, so I got to get up to, what was 5?
489.
Or
It's 489.
91, it says here. Did I plug it in right? 4x cubed minus 2x minus 1. Here's your 89. Okay.
Why do you have to?
Oh, shoot.
Yeah, can you just do
Well, yeah, we need a visual. We need a, this is not about all plugging and chugging, Missy. Because it doesn't always work. We need it to. All right, so what should I put in for my window? I need to accommodate 0 to 5, so -2 to 3 would not work. Let's go with -2 to 6, okay? What should I put in for my Y minimum? I need -500? Okay. All right, I don't want all that. All right, let's see what this works. We're just interested in between 0 and 5. There we go. Okay, so this is just the piece. We cut off the other piece that was down here. 0, 5, 1, 2, 3, 4, 5 is right here, right? And 0, -1. Oops. How come the -1 didn't show up? Just barely. Okay, so this secant line looks like this, except it's totally missed. Okay, if I remember correctly, you all kind of looked at me like, secant line, what does that mean? So here's why I'm doing this. Make sure you can, you know visually, hopefully, what a secant line is. You're just going to find a regular slope. So 489, is that right? All right, what's my slope? 490 over 5? Okay. Now, that's a big difference from -2. so big of a difference, because the tangent line looked like that. Sometimes they're going to be close, sometimes they're going to be way different. But that's a big gap. Okay. And E, what's the equation of the secant line?
Doesn't matter which one E is.
Nope.
Y plus 1.
Y plus 1 equals 98x. Okay? That would be the same graph in there as y plus minus 489 equals 98 times x minus. Either one of those would work. Okay?
The first one you said.
It is, yes. And that would be the one Emma's going to pick every time, because she's very efficient. Okay? I mean, I'm serious. Isn't it?
I agree.
It's 89, sorry.
Whole job we did for a week.
You all have another bad habit I'm going to point out. You don't listen to each other's questions. And they're very important because they're always good questions. Go ahead.
Where did you get 490?
490, I did 489 minus a negative 1. I had figured you'd already done it, so that's why I just jumped right here. Okay. All right. Anybody else? Yeah, if you graph those on the same, they would give you the same thing. I can actually show you. Okay, did y'all notice I turned my derivative thing off? You know how to do that?
No.
Okay, so I just kind of leave it in here, and you can leave it down here if it's going to be in your way, and just turn it on and off as needed. But let's go over to the equal sign, and if you press enter, now it's highlighted. That means it's on. Go back over there, press enter again. Now it's not highlighted, it's off. So it's not going to graph for you. Okay? If you clear it and then re-enter, it's automatically on until you turn it off. All right? So it's off, and I'm going to put this in. Negative 1 plus 98x. That's my tangent. That's my secant one. What was my tangent one? Let me put that one in there too. Tangent's purple. Negative 1 plus 0.5 x is negative 2 minus 0. That's the normal one, right? Okay, so I got them going, all going in here. Let's see what we got. Mess, but okay, that's my secant one. That one's my normal one. But they're probably so close that they're not showing us the difference. But you can see green and purple should not be the same. But because of my scale was so weird, if you remember my scale was by 10, it's not going to show up too much different. Okay? All right. Turn the recording off.
Hi, Molly.
Bye.